What do you mean by a capacitor microphone? My name is Rishi Remju and welcome to the Backbench Engineering Community where I make engineering easy for you. So let me ask you guys the obvious question again. What do you actually mean by the term a capacitor microphone? Well, let's find out. Well, a capacitor microphone is a type of capacitor transducer. A transducer is a device that converts a physical quantity into an electrical signal. But in the case of a capacitor microphone, what it does is that it converts sound waves into an electrical signal. That is what a capacitor microphone does. But how does it happen? How does a capacitor microphone convert a sound wave or a sound signal into an electrical signal? For that, it uses the principle of capacitance of a parallel plate capacitor. So let us first take a parallel plate capacitor like this. It consists of two parallel plates like this. And now here, if the distance of separation between these two plates is given as d, then we know that the capacitance is given as C is equal to A into epsilon divided by d, where epsilon is the permittivity of free space. So here, for us to utilize this particular parallel plate capacitor for the purpose of constructing a capacitor microphone, what we do is that one plate must be able to move, but the other plate must be kept as fixed. It must not move. So let us fix this particular plate. For that, we place a holder like structure like this over here. So therefore, this is a holder. And therefore, because of the presence of this holder, this particular plate is kept as fixed. This is a fixed plate. And now what we do is that we extend this holder a bit more like this, such that this particular plate can move like this. That is, a parallel motion like this is possible for this particular plate. Therefore, this is a movable plate and is referred to as a membrane. So now we have two plates separated by a distance d, and now here what we do is that a DC voltage is applied between these two plates like this. We now apply a DC voltage between these two plates like this, and therefore when a DC voltage is applied, a capacitance of C is equal to A epsilon by d is developed across this particular parallel plate capacitor. And now let us imagine that somebody is speaking over here and therefore sends a sound wave like this. And now, because of the presence of this particular sound wave, this particular membrane starts vibrating like this. And here, because this particular membrane starts vibrating, this particular d starts varying. And therefore, as the distance between these two plates start varying like this, it keeps on varying. Because of that, according to this formula, this implies that C is inversely proportional to d, because C is equal to A epsilon by d. Therefore, as the distance decreases, the capacitance increases. So it is inversely proportional. So now here what we observe is that we know the formula Q is equal to CV. That is, the total charge enclosed in a particular capacitor is equal to the product of the capacitance and the voltage. So therefore, from this we observe that V is equal to Q by C, because here the charge is constant. The charge is not varying because it is a DC voltage that is being provided, and therefore the charge does not vary. The charge is constant. But what varies here is the capacitance. So as the capacitance varies, the voltage also varies inversely to the capacitance. Therefore, V is inversely proportional to C. Therefore, as the capacitance increases, the voltage decreases. And as the capacitor decreases, the voltage increases. As simple as that. So here, when somebody is speaking through this particular microphone, the membrane starts vibrating. And now, when the membrane starts vibrating, for example, if the distance decreases, then the capacitance increases. And as the capacitance increases, the voltage decreases. As simple as that. So here, as the distance increases, the capacitance decreases. And now, as the capacitance decreases, the voltage increases. And now if the distance decreases, the capacitance increases. And if the capacitance increases, the voltage reduces. So this is the basic principle behind a capacitor microphone. So now here, if we take a particular load resistance like this, an output voltage can be obtained across this particular load resistance, and therefore we can obtain a particular output signal. That is, whatever sound waves are hitting this particular membrane is converted into an output electrical signal. As simple as that. This thus is the basic principle behind what you refer to as a capacitor microphone. As simple as that. So a capacitor microphone is also referred to as a condenser microphone. A condenser microphone is usually used for the purpose of recording vocals for the lead vocalists in bands so that they obtain an actual crisp electrified version of the vocals. That is why we mainly use a capacitor microphone or a condenser microphone. So I hope you guys now have a clear understanding of what you refer to as a capacitor microphone. And if you guys found this video informative, do hit the like button and join this community by hitting that subscribe button. We'll be discussing about the further topics in the upcoming videos. So stay tuned, stay subscribed. Until next time, I'll see you guys in the next video. Thank you.